Hi, my name is Isabella Villarroel. I'm from Chandler, Arizona, and I'm a rising sophomore here at the University of Arizona studying medicine.
Hello, my name is Ethan Villarroel. I'm an undergrad here at the University of Arizona going into my sophomore year, and this is my third summer in the Dr. Villarroel lab. Alright, so opioids are a big problem in the United States. Over 2 million deaths have occurred since 2021 with any type of opioid and synthetic drugs. That includes fentanyl and morphine. And what we do to contribute to the problem is doing perfusions and tissue collection after cervical dislocation.
So throughout the summer, our goal was to do 300 mice because the machine that we've been working with, the blood blast analysis, only takes a certain amount of numbers within a certain amount of time. So we only had a month to do 300 mice, and with this, I would get the blood from the mice after the perfusion was done and inject it in here, and this machine measures the oxygen levels and the carbon dioxide levels and stuff that we need to essentially test the compounds that were given to the mice, so morphine and fentanyl.
And it was a 4-man team. Us two plus a PhD student and a lab manager helped contribute to the project. And what we do is we would do perfusions. So this is the setup we would do perfusions in. We would put a mouse. First we would inject the mouse with an opioid, and the first opioid we did was morphine. So we would put the mouse in the chamber under isoflurane, and then once it fell asleep, we would then place it on here with a nose cone so it could still go under. And then we would do a toe pinch to make sure it was not feeling any pain. And then what a perfusion is that you open the chest cavity to see the heart still pumping. And then what you do is you inject liquid into the heart in order to remove all the blood from the lungs and brain, because we're collecting those. And then after that, we would use the blood gas exchange analysis by sucking up the blood from the heart. And then after the PhD student was done with the perfusion, he would hand off the mouse to me, and then I would be sitting here with the dead mouse, and then I would first remove all the blood with chem wipes. Here's some chem wipes. And then after that, I would get the spleen and the lungs, and then I would put it in plastic canister like these tubes, put them in here, and then I would put it in this box full of dry ice. And then once I would then grab the brain, harvest the brain, I would put the brain in here for 2 minutes because the brain comes out all sticky and gooey, and you try to freeze it in order to harvest it. So you put it in here for 2 minutes, and it was really challenging at first. It's almost like, I'm trying to think of an analogy, it's almost like cooking steak. When you cook steak, you want it not like hard, or you don't want it too soft, you want it perfect in the middle. And so that's what you want to do with the brain. So when you take it out and you put the brain in and it's frozen, then you use blades. Then you would slice different regions of the brain. Then you would place it on this paper, then use this to then select different regions of the brain. And the different regions of the brain are PBC right here, and KF and PAG. We analyze those different regions of the brain because that helps homeostasis and the respiratory system.